Okay, section 5.3, question P30. And we have one of these contingency tables again that you'll get quite used to here in chapter 5. Again, just to remind you, this row of totals right here is the total of everything, including the totals column. So whatever these two are, they will total up to 100,000. Same thing, this total column is the total of each row, including this 100 as a total of these two numbers. So this is kind of like a crossword puzzle, really. There's spaces that you have to fill in, and there's clues that you're given, and based on what you get on one, you can kind of get better information for another one. So if you think of it as a puzzle, it's maybe more enjoyable. And then actually, this is a really neat question because it shows something very unexpected, and we'll talk about that at the end. But I think it's a very common misconception in society, and if you're in the health field, it's very relevant to you, or athletics. Even if you're not, I think you'll be surprised by what we see at the end. Okay, so we have this lab screening test. It gives a positive result for 4% of the time for people who do not have it. In other words, this is a false positive. So 100 people that do not have the disease, they all take this test. About 4 of them are going to show up as having the disease, even though they don't. So false positive. False negative, 0.4% of the time. So 1,000 people with the disease, 4 of them will show up as not having it, even though they do. And then we have the disease occurs in about 3%. So overall in the entire population, about 3% of them have it. And we have this table for every 100,000. So we're just gonna, we have percentages here. We're just gonna adapt that down to a chunk of 100,000. And this is often done, you may say that, of people who get, of 100,000 people who get malaria, you might have 3,000 of them die or something. So this is often used for health-related issues. So where to start off with? Well, I notice here that it says 3% of the entire population has the disease. You know what? Let me start from the beginning, and I'll show you why I don't start there with my crossword puzzle. So positive result 4% of the time for people who do not have the disease. So what that's saying is this right here will be 4% of this, not of the overall total, just the people who do not have the disease. So whatever this number is 4% of it. But because we don't have either of them, we really can't do much with it. We need something that's going to use this 100,000. And the only thing that we're given that uses that 100,000 is this 3% right here. So we know that 3% of the population has the disease. In other words, 3% of this 100,000 will have the disease. So what is 3% of 100,000? 0.03 times 100,000. And you should get 3,000. So that's the amount, that's the total amount of people with the disease. So I'm going to go ahead and fill that in. Now notice, as soon as I get that, any row or column that only has one entry missing in these tables, you will be able to fill out. So I know that these two have to add to 100,000. So I take 100,000 minus 3,000 to get 97,000 do not have the disease, which makes sense. 100,000 people, 3,000 of them have it, 97,000 shouldn't have it then in that perspective. Now we've already talked about this. We know that this number should be 4% of whatever this 97,000 is. So let's, this goes a little bit beyond my range of mental math here. Let's take a look at, looks like I already had my calculator pulled up. So I'm going to take 97,000 times that 4%. That's going to give me 3880 here. Okay, as soon as I get that, now I have 2 of the entries. I have all but 1 of the entries in this row. So I can just take the total minus this to get that, and that should be 93,120. Okay, now I'm stuck again because I can't get either of these. So I'm going to use my other data point here. So with this 0.4% of the people who do have the disease, so of this 3,000, for 0.4%, so 0.004 of this 3,000 will have a negative result. That's what that said. So 0.004 times 3,000 would give me 12. And boy, this just opens up the doors in the crossword puzzle now, because look, I can take these two numbers, subtract 12 from 3,000 to get 2,988. And as soon as I get that, I can just total these two columns. Little harder here. Let's see. We would have 6, 8. It's always harder doing multiplication from the left, or addition from the left side instead of the right. But I believe that's right. And you know what? We'll find out soon, so I'm not that worried about it. And here we get 93,132. And if I've done everything right, this is another cool thing about these tables, these two should add up to give me 100,000. Well, 6,093 gives me 99,000. Adding the other two, I get 1,000. So yes, that is 100,000. So I do know that all my numbers there are correct. Please do check at the end, because I'd hate for you to miss one of these tables just because of a adding or subtracting error. Now, what is the probability that a person selected at random tests positive for the disease? And it looks like I have my calculator already up here. Okay, selected at random tests positive for this disease. So notice it doesn't say has this disease, it's tests positive. We know that 6,868 people tested positive, and I really don't even need my calculator here because the probability, now I hope they're going to take this, would be 6.87%. And let's... I suffer from the same frustrations as you in terms of the decimal places, and I'm hesitant here. I'm wondering if they're wondering 3 past the 0 or 3 total. You can try either way. This is one of the reasons I've raised the limit to 10 tries. So what is the probability that a person selected at random who tests positive for the disease does not have the disease? So blah, 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 blah. What we're really looking for is if you're one of these people, you obviously don't know if you're in this category or in this, but it's very important. Say you test positive for HIV. You want to know if you're a true positive or a false positive. That's a huge life difference. If you're a randomly selected person for drug screening in high school, or your child is, and test positive, does that mean that they probably are using the drug? Well, let's take a look in this specific case. So if you're testing positive, what's the chance that you don't even have the disease? Well, that would be these people over the total. So it would be 3880 divided by 6868. 56. Clicked it too quick. Let's go 0.565. Over 50%. So getting what that is, these are accurate tests. So 96% of the time, if you have it, or if you don't have it, it'll let you know that you don't have it. 0.4% of the time, in other words, 99.6% of the time, if you do have the disease, it'll let you know that you have the disease. So we're not talking about an inaccurate test here. These are reasonable. 96% accurate if you don't have it, 99.6% accurate if you have it. And yet, if the test shows up as positive, in other words, it tells you have it, you would think with those high levels of accuracy, it's pretty sure that you do have it. Not at all. 56% chance you don't have the disease. Okay, so this is a kind of weird thing about conditional probability, but this is perhaps one of the most important questions of the course because I think it goes so much against what you hear. If you have some kind of test that you take, a pregnancy test or a test for a fatal disease or something that's a very serious thing to you, and it comes back positive, well, not only do you need to check the false positive rates, the true positive rates, you really want to get into the data and know what your chance is of having it if you test positive. Because there could be a very strong likelihood that you don't have, especially if you were randomly chosen for something, which of course isn't as likely. But with drug screening tests, that is likely to be the way that they do it. So just keep this in mind. Let me know if you have questions about the implications here.